In this video, we're going to talk about creating simple satellite images. To begin, we're going to need to talk about where satellite data can be found. Because of our online nature this spring 2020 semester, we need to find a resource of satellite data online. Luckily for us, Unidata offers such a repository. And so where we need to look, if you're following along on the handout for the Python portion of satellite images, on page 1, we have the link that we need to go to for threads.ucar.edu. Now again, if you've got this in digital form, you can click on that link that's available there, or just type in threads.ucar.edu, hit enter, and you'll get to this initial landing page. And specifically what we're looking for here is satellite data. So go ahead and click on that satellite data, and you're taken to all the various available imagery that we have. What we're going to care most about this semester are our GOES East and GOES West datasets. Specifically though, we want the GOES East products and the GOES West products. This is where we're going to pull our data from this semester. As you likely have previously learned in other videos related to just satellite operation in general, our satellites have a wide range of products available. And so let's go ahead and click through on GOES East to see what these products are and where we're going to find our necessary data sets for current data. I must reference here that we are looking at current data. Your homework assignment is going to look at past data, which is in a different location and unfortunately formatted slightly differently, but not too much. Mainly just in the file names. So let's go ahead and click on GOES East, and you can see there are a whole bunch of different products that are available. And the one that we care most about are things that are related to clouds and moisture in the atmosphere. So specifically, we want to come here to the bottom and look at our cloud and moisture imagery file. So if you go ahead and click on that, there are a couple of different regions that we can look at. Specifically, we want to look at things that are CONUS level for the purposes of this class, but you can feel free to try to make satellite images using some of these other regions as you desire. So let's go ahead and click through to CONUS. And here's where we see our 16 different channels worth of information. Channel 1 and 2 being more classic visible channels, 3 being the veggie channel, and then we move into various infrared and water vapor channels in 4 through 16. Some are near infrared, some are far infrared, but it's a combination of different things. Again, I refer you back to the meteorological video on satellites for more information. Let's go ahead and take a look here at just one of these channels. So let's go ahead and look at channel 9. Channel 9 is our classic water vapor channel, around 6.7 microns or so. Go ahead and click here, we see that they have data for the past couple of days. And so we see data available from March the 17th through today's recording, March 30th. This is a rolling window. And so tomorrow, March 17th would roll off when we would gain March 31st. Let's go ahead and look back one day at March 29th here. And we can see this files, all the files that are available. From our GOES imagery, we have data available roughly every 5 minutes. And so the times are baked in here to this S, E, and C. It's the start, end, and center time of the scan. Now, this is a lot to take in. It's year, Julian day, and then time in hour, minutes, seconds, and microseconds. When we get to looking at our first notebook, we're going to have a solution in terms of a definition to help us find the appropriate time for the file that we desire. But let's go ahead and click on any one of these. And so we'll click on one of these from 19 UTC, here from 1916 UTC. We're taken to our threads data page here, of which what we really care about is this OpenDAP link. The OpenDAP link is what's going to work for us in our Pythonic environment. And if we click on that link, we're going to be taken to the page, the OpenDAP page, about this file. And so the most important thing here is our data URL. This is essentially what we're going to be creating in our notebook. You can see it goes over for quite a ways here. But if you double click throughout this whole data URL. You could copy and paste out of here if you need to. But we do get other information on this page. For example, we have one variable called sectorized_CMI, or sectorized_cloud and moisture imagery. That's what CMI stands for, cloud and moisture imagery. Available at Y and X coordinates with a fixed projection. So there's very limited data, but our total is actually quite big, because here in this channel 9, we are at a 2-kilometer spacing between each one of these cells, these raster cells. And so this is where our data is going to come from for plotting our current data. So let's actually do that. Let's actually work on creating a satellite image. And so we want to go back to our Jupyter Hub environment here. And specifically, if you're at the bottom of page 1 in your handout, we want to find the notebook that is called satellite_imagery. So let's go ahead and duplicate, shove our copy into our working directory, go into our working directory, rename our file to be my first sat image. Go ahead and double click that, get her open here, and we've got ourselves a nice working notebook. Some important things to note here. We are going to be using Siphon to gain access to these data files from this thread server in a similar way to which we got our Iowa State upper air archive. But in this case, we're going to use this class called TDS catalog, or threads catalog, to help us gain access to that information. For plotting purposes for our satellite, we're going to be using ImagePlot. Because what satellite data is essentially an image, we're going to want to use ImagePlot to plot a raster image as opposed to using a color-filled image. And so ImagePlot is what we want to use in this instance. Otherwise, most everything else is the same as what we've been using most of the semester, so we're going to go ahead and run our import cell here. Whoops, and I got myself an error again because I hadn't run this one yet and changed my kernel. Go ahead, changing the kernel. Kernel gets all reset up, and now we'll be able to import all of our modules. This next cell is a definition that's going to help us find the appropriate file for the time that we desire. Outside of knowing that this definition is here and that's what it does, that's really all you're going to need for this semester. And so if you need this in another file, for example, if you're making an image from for your map journal or something like that, just copy this cell over along with the imports and other things, and you can feel free to reuse this. We'll use it down there, and I'll show you where when we get there. All right, getting past these first two cells, we are now getting to the cell where we're going to get our data. And so here we are setting up the date and time of the data we want to grab from the thread server. Here we have our year, month, day, which I'm going to change to the 29th, hour, and minute. So here we're specifying all through the minute because we get data every 5 minutes, and we want to find the data that's closest to the time we desire. So we may not have data exactly from 1530, but we can probably get something pretty close since our data comes every 5 minutes. And if you're reading along on page 2 of the handout, what we are ultimately trying to do here to gain access to the satellite data is to generate the appropriate URL or web address for our satellite data. To do so, I've created a couple of variables. Now, why did I create these couple of variables? I did this so that in case in the future I want to change my region, instead of being CONUS, maybe one of those mesoscale sectors, I could just change it right here and it should work throughout. More similarly, our channel number. Right now I've got this set for channel 9, but it'll be pretty easy to switch between channel 9 and channel 2 and channel 14 for whatever you need to create. And we're going to primarily focus on goes east data, but all of this should work from goes west as well. And so we're using these three variables so that in the future, if we wanted to change them, it'd be easy to generate this whole link and use all those pieces where we need. And so you see here we use our satellite, here we use our region, and here we use our channel, and here we use our date. And so we are limited to finding the data just available on a given date. it would be quite a bit harder to get data that spans over 2 dates in just one fell swoop. And so once we've set up this URL, that's what we're going to feed into our class from Siphon, this TDS catalog. And that's going to gain us access to all those OpenDAP addresses without us having to go in and copy it directly. Although one could do that and put it into our Xarray for reading purposes. And so then here in this next cell, we are going to use this homemade function, get_satellite_file_URL, feeding in our data sets that we get from our catalog and the date we desire. And so when the program gets to this line, it's going to go back up and use this function that we defined up here and output something that's going to allow us to pick the most appropriate OpenDAP URL and use that for getting our data. And so once we do that, we're going to select our data set, and then finally we're going to access our data set in an Xarray type way, and so that's why we have use_Xarray equals true here, so that we basically get our commonly used Xarray data set at the end. Since we don't know the time exactly because this file is from kind of any 5-minute period, we're going to take our time from the data set, grab the value, and convert it into a date-time object. That's what this as type stuff does at the end. It's basically going to create it into a date-time object for us and set it equal to our variable called vtime, which is short for valid time. So let's go ahead and give this cell a run. It doesn't take too long since we're accessing just a single file, and we can get on to plotting. Here we're using our classic declarative metpy syntax, and our last two things are just our common panel and panel container elements that collect things that we're going to plot on our image. This first sector here is the bare bones basics that we need in order to create a satellite file. And so we are starting with our image plot class. We are setting the data to be from our dataset DS. The field that we will plot is that variable name sectorized_CMI or sectorized_cloud moisture imagery. And the color map we're going to use are just gray. So we're just going to get a black and white kind of grayscale image here. And then on our map, we're going to plot coastlines, borders, and states. Give it a fancy title here. And so I use some funky formatting stuff from Python. Feel free to Google and read about that. But what's basically happening here is, one, we're putting on the left-hand side and saying 123 spaces from the middle to the left-hand side. And then for our valid time on the right-hand side, 123 spaces to the right from the middle. There's no magic here to the 123. It's based partially on the size of the figure that you create. And this is going to put it kind of nicely out at each edge. Again, you don't have to use this. You can just plot everything based on the center. And so that's it. It's pretty easy to get a satellite image, and let's go ahead and run that. And sure enough, there we go. We've got our GOES East water vapor channel 9 imagery. And we see this is from Sunday, March 29th. And we see this big cyclone that was over the center part of the country that had caused all that severe weather on the 28th throughout the Great Lakes region. And so we see our moisture values here are where we see the strong white colors is where we have a lot of moisture all feeding up and wrapping into the system. We see almost this dry conveyor belt going on with our satellite image over Ohio at this particular time frame. So that's it. That's pretty easy to get a satellite image. Let's go ahead and just change our channel. So instead of channel 13, let's say we want channel 14. And so since we're just changing the channel, we just have to rerun this particular cell to gain access to our different file. And then here, instead of a water vapor channel, now we're going to have channel 14, which is an IR channel, so we can make a small little change there. And we can run it and get our IR channel. Again, just using our grayscale imagery. In a future video, we're going to talk about how we can color enhance this imagery to get even more information out of it as an end user. Now, one thing you may want to do is to go ahead and save these images, and so we can set that up, pc.save, and then we're going to use a format string here, and so I'm going to say GOES_East IR underscore channel underscore. Now here is where I'm going to use a variable, so I'm going to use that channel variable. And I want to make it 2 digits long and 0 pads, so 02D is going to do an integer of 2 digits in length, padding with a 0 in front. Underscore, and then vtime, and we're going to go ahead and format that %y, %m, %d, underscore %h, %M. So we get that hour and minute there, .png. Then we're going to bbox underscore inches equals height to remove excess white space and set our DPI value equal to 150. Let's go ahead and give that a run. It'll take just a couple more seconds to run since we're going to save our file. Once it completes, give it just another second here and we'll see it complete and generate our image over on the right hand or over on the left hand side. I'm going to give that a double click and open it up to make sure it in fact did save. And look at that beautiful plot that we made. Looking at our infrared temperatures here. In order to download this, we can right click, download as, and save to our local space somewhere. So maybe I'll go ahead and save this to my class directory here to save that off. That's it. Pretty easy to make a map. And so hope you found this useful.